Welcome all for today's interactive session on attachment retained denture. We will see what is attachment retained denture or what is an attachment. An attachment is a mechanical device for the fixation, retention, and stabilization of a prosthesis. This is the definition given in glossary of prosthodontic terms for attachment. So in some cases, we use attachments for better retention of the denture rather than going in the conventional way. There are advantages and disadvantages in relation to these kind of attachment retained denture. The advantage being it is more aesthetic uh, and it is more retentive compared to the normal dentures. But the commonest disadvantage is the difficulty in fabrication, the cost of maintenance, and the periodic checkup the patient has to undergo, which will be quite more in number compared to the normal RPDs, which we fabricate using clasp and direct retainers. So these are the setbacks and advantages. But in the present scenario, many of the patients are opting for attachment retained denture. So it is mandatory that you know what are the different aspects of attachment retained denture. That is why this topic is relevant for today's interactive session. So moving on, these are the different synonyms which we commonly use for attachment retained dentures. They are called as precision attachments. They are even called as parallel attachments, frictional attachments, internal attachments, key and keyway attachments, and slotted attachments. So you can have questions with the synonyms on, but the answer which you have to write will be the same for attachment retained denture which you have learned. Attachments in the denture usually have two parts. One part is called as a male part, which is usually called as the matrix, and then you have a female part which is being called as the patrix. So it is the mechanism between this male part and the female part which contributes to the retention of the prosthesis. One will be engaging will be engaging into the prepared tooth or the abutment which receives one part, and the other part will be incorporated onto the denture. So there is a different there is a mutual bonding or a mutual mechanism by which it is being held together. That is why it is called as attachment retained denture. So what are the different applications of attachment retained or denture or attachments? It can be used in crown and bridge restorations. Since we are talking about attachment retained dentures, obviously it is a part of partial denture restorations, and these kind of attachments are used in over denture restorations also, and in some cases of implant restorations also. Since we are talking about the retained denture, attachment retained denture, we will be looking on that aspect only. We will be covering over denture restorations in a different scenario or a different word under a different topic. We won't club the attachment retained denture and over dentures together. So for you, it will be basically the classification which is of quite importance with respect to the attachment retained dentures, or this will be the possible question which you will get: how you classify the attachment retained dentures. So the classification for the attachment retained dentures is based on how the attachments are there in the prosthesis. So the different modalities under which it is been classified are the fabrication, then the location, function, and the mode of retention. These are the four aspects based on which the attachments in the attachment retain denture are being classified. So that will again lead to the classification. So we will see each of the category individually. Under fabrication, it has been broadly divided into precision attachments and semi-precision attachments. Precision attachments, as the definition goes, it is a retainer consisting of a metal receptacle and a closely fitting part, usually contained within the normal or the contours or expanded contours of the crown on the abutment or when in the dental implant. And the matrix is attached to a pontic or removable partial denture framework. So the thing which you have to remember is in precision attachment is it the components, that is the male part and female part, are machined. It is not waxed up, and we are not creating that part. It has been machined. So you know, when a material is machined, the precision of that machined part will be very close to accuracy. That means you don't have any deviation. You need to have if you say you would have a tolerance, it is called as the term will be tolerance. The tolerance will be very less. That means you don't have any changes. The precision, the way which the male and female attachments come together will be too close that with our naked eye we cannot say which is the male part and which is the female part. So the closest approximation between the male part and female part will be there with the precision attachments, since it is been machined. So the precision attachments, to say that it is machine, that makes it different from semi precision attachment. So the advantages with precision attachment, it is more precise, and it will be more retentive since the precision is too good, and we cannot modify that because it is been machined. So the part A which is being machined will suit to part B which is being machined only. We cannot modify. Whereas in semi precision attachment, what happens is we fabricate it by means of casting procedure, casting the wax pattern or casting the plastic pattern. So since it has been casted, you can modify it. That is, there is more space between the male part and female part, and so what happens is the precision will not be very accurate as the machined components which is being fabricated in precision attachment. That's why it is called as semi-precision attachment. The advantage with semi-precision attachment is you have more tolerance. That means the retention may not be as good as that of a precision attachment, but it do provide some amount of retention. It is economical. You can modify it because you have casted it and you are created it. So if anything goes wrong, you can modify it. It is more economical compared to the precision attachment, and you can use different materials for fabrication because you can use a noble metal alloy or you can use base metal alloy because you are fabricating it. But when it comes to precision attachment, it is being manufactured by means of the company, and if anything goes wrong, you have to redo the entire procedure or you have to buy the entire components from the laboratory, and you need to attach it to the removable partial denture, or you need to do kind of modifications with respect to the tooth preparation which you have done for receiving the attachment. So these are the broad classification based on fabrication, that is precision and semi-precision. Precision is machined components and semi-precision is the components you are either you are casting it out from the plastic or wax patterns. So the next classification was location. Based on the location, you can have extracoronal and intracoronal. Then you can have on the radicular part of the tooth, wherein you have stud attachments, bar attachments, or magnets, and you have auxiliary attachments which is been not present as part of the coronal tooth structure or radicular tooth structure. It will be away from the tooth structure. So stud bar and magnets we will be discussing more in over dentures. So these are the classification based on location: extracoronal, intracoronal based, then radicular. Under radicular we have stud attachments, bar attachments and magnets, and auxiliary attachments. Then this is the classification based on function. You have class 1, class 2, class 3, class 4, class 5 and class 6. So class 1, it is considered as solid and resilient. Solid and resilient. In class 1 you have class 1A, which is solid or rigid, and class 1B, that is which is solid, rigid and with a lockable. Then you have class 2. So class 1 has got two parts, A and B. Class 2, it is resilient, that is from class 2 to class 6 it will be resilient, whereas you don't have any resiliency with class 1A and B. So class 1A and B based on function is rigid. Class 1A is rigid, class 1B is rigid with a lock. Class 2 is resilient category, that is class 2 if you say it is vertical and resilient. Class 3 it will be hinge and resilient, that is from class 2 onwards till class 6 you have resiliency with the attachment, whereas class 1 you don't have any resiliency. I am telling this again and again to make sure that that goes into your mind, that is the class 1 it doesn't have any resiliency. Class 1 is considered as rigid or solid, and class 1 has got two subclassification, class 1A and class 1B. Class 1A is just solid, class 1B is solid with a lock attached to the attachment, that is rigid and lockable or solid and lockable. That is whatever I have entered in green is resilient, whatever I have entered in red is solid. So the based on the function, attachment is being classified into 6 category. First category is solid category or rigid category, and from 2 to 6 it is resilient category. Hope it has been clear. And class 1 is solid. It is been divided into subclass A and B. A subclass A is just solid or rigid, and the subclass B is it is rigid with lock attached to the attachment. Class 2 is it comes under resilient with the vertical component of motion, that is vertical and resilient. Class 3 again resilient with a hinge component of motion. Class 4 it has got both vertical and hinge motion. Class 5 is rotational and vertical motion with resiliency, that is rotational and vertical, that is it allows some amount of rotational and vertical movement. And class 6 is universal rotation, that is it allows movement in all planes. So you need to remember this classification, and you need to remember the examples of attachments which come under each classification, which we will be seeing in the next slides. Under class 1A, that is rigid and it is non-resilient, it is class 1A, it is just rigid. So under that you have Baylor's attachment. Class 1B is rigid with a lock, that is you have score PD. The example for a class 1B attachment is score PD. Score PD. Class 1A attachment, example is Baylor's attachment. Class 1B, that is rigid with a lockable mechanism, you have score PD as the example. And class 2, it is vertical, and at the same time it allows a vertical movement, and at the same time it is resilient. That is, from class 2 to class 6 it is been resilient with a vertical component of motion permitted by the attachment. Under class 2 you have TSE and Allegra attachment. These are the examples for class 2, TSE and Allegra attachments. You can Google it and see what are the attachments, how does it look like, if you are very much interested. If not, you just remember the name. These are the examples which comes under class 2 category of attachment. For class 3, again it is resilient but allows a hinge movement. So since it is hinge, AI hinge is the example for the attachments which comes under class 3 category. And class 4, as we had seen earlier, it allows both vertical as well as hinge movement. An example for class 4 is Dalbo attachment. And class 5, again it permits rotational and vertical movement mm, for the attachment. And the example are Sika attachment or ASC 52. It provides, or it gives a rotational and vertical movement. That's this relation of the attachment. That's why it comes under class 5, Sika attachment and ASC 52. And class 6, it promotes, or it gives movement in all the planes, that is omniplanar. And the example for class 6 attachments are stud attachments. So these are the classification of attachments which is been present based on the function, the function, that is class 1 to class 6. Class 1 is solid in category. Class 1 has got two sub classification, and class 2 to class 6 is been resilient, and it is been divided based on the permittivity of motion in which plane it is been moving. That is the reason for classification from class 2 to class 6. So you need to remember all the class 1 to class 6 with the examples. That is, if you want to, as I told earlier, if you want to know more about the different attachment based on function, you can Google it and see the different attachments, or you can refer the textbook wherein you can get the different pictures of the different attachments. So that is the classification based on function. Now, based on retention, the attachment is again divided into four category. That is frictional, mechanical, a combination of frictional and mechanical. That's why it is called as combination, and the magnetic. So here the retention principle is the factor of classification. In frictional, what happens, as you all know, the retention is been provided by the resistance to the motion by means of the closeness of two or more surfaces, because of the intimacy of contact with each other. So if you have two parallel surfaces which is very close to each other, then it is usually a frictional attachment. Then mechanical attachment, under frictional attachment, if you would like to say anything, Bailey's attachment, I think Bailey's attachment comes under frictional attachment. Please refer the textbook if for the exact example for the attachment, frictional attachment. For mechanical attachment, what happens is it is been provided by the presence of some kind of undercut which you utilize for mechanical retention in some kind of undercuts which you create, and the processes, the parts will be engaging into that undercut, and that will provide retention. So that undercut, the presence of undercut is the mode of retention under a mechanical attachment. And in some cases, both the frictional as well as mechanical comes into picture. That is why we have a combination wherein you have the undercut as well as you have the frictional part. That is, will be like you will have a area where some area where it is because of the friction, and some area because of the undercut. So since it has been a combination, you can have both the aspects incorporated into the attachment. And finally, the magnetic, where you have the resistance caused by means of magnetic attraction, that is the like poles or unlike poles comes together, and unlike poles come together and you will have an attachment. That is why you have the magnetic attachment. The like poles repel, whereas the unlike poles of the magnet attract together, and that attractive force is taken into picture or taken into consideration for the retention for the prosthesis. So this is the mode of or I mean the classification of attachments based over danger, or I mean prosthesis removable partial danger based on the mechanism of retention. So you have different aspects which you can consider. That is the method of fabrication, in the location. You have the function. You have the retention. Different principles you have. Under different principles, you have different attachments. So you will be confused which attachment do I need to select at a particular stage, since you have a lot of possibilities available. So you select your attachment based on these things: the location where you are deciding to give the attachment, whether it is been extracoronal or intracoronal or radicular or auxiliary. Then based on the function, whether you want your attachment to be resilient with a vertical component of motion, or whether you have a solid attachment which you want. So based on that, if you want to have a solid, you can go for a class 1 with the lock or without lock, depending upon the subcategory A and B. If you want vertical motion, that is resilient, then you will go for class 2. When if you want a hinge component of motion, some amount of hinge movement you are planning to give for your attachment, you can go for a class 3 attachment. So that is how you AI hinge class 3 attachment. So that is how you select your attachment. So based on function, you have the opportunity. So it is a permutation and combination of all the factors: the location, the function, the mode of retention which you would like to provide, the inner arch space availability. You cannot use in some attachments require space more than 5 millimeter. Some space, some patient does will not have that much of space. So you need to go for a attachment which takes up a very minimal amount of space, and the cost which the patient can bear. So each attachment, the cost can vary depending upon how it is been manufactured, whether it has been a precision kind of attachment or whether it is going to be semi-precision attachment. Um, Depending upon the companies which provide, depending upon the function, how much of function is provided. So it is a combination, permutation and combination which you will look upon in deciding the attachment. So various factors which you need to consider when you select an attachment for your attachment retained removable partial denture will be location, function, retention, space and cost. I'm not going into detail much regarding this, because you need not learn in elaborate regarding all these things. So I'm just giving an outline regarding all those things. You can refer the textbook if you want to clarify more, if you have any doubt, or if you want to learn more. And you can, if you have any doubt, you can anytime post your doubts in the WhatsApp group, and we will interact and we will clarify those doubts. So that is about attachment, the different problems which you would encounter with these kind of attachment retained over danger, or I mean prosthesis will be appearance. Some cases, if it is been extra radicular, you have the metal component jetting out, which might look awkward in certain situations. Then the amount of retention. So as you all know that there are different attachment based on function, so the retention provided also will vary. Then the path of insertion, differing physical properties of materials, the availability of space, and the manual dexterity of the patient. So if you get take a complicated attachment, it will be difficult for the patient. So age of the patient has to be taken into consideration for whether he'll be able to place it properly. If he is not able to place it properly, then there will be chances that more repair required, or more adjustments required, and the wear and tear of the attachment also will increase, which again will compromise the prognosis of the prosthesis. So these are the problem areas which you could encounter when you give retention supported processes. So with this, I would like to wind up my session on attachment retain danger. So you have to remember the different classification. That is the most important aspect of attachment retain danger. That can come as a short note, or it can come as a short essay. The classification, how it is been classified based on function, based on location, based on retention and auxiliary. The uh, aspect which you need to look into. Other thing is the different synonyms which you can you are going to get as a viva question, different synonyms for attachment retained dangers. So if you have any doubt, you can post it in the group. We will discuss it. This is a small topic which needs to be covered, and most of the time there is a possibility that it is can come as a short note, nothing more than that. So if you feel free to post any doubt, and just go through the presentation, and try to remember the classification of the attachments with the examples. And that's all for today's session. Thank you.